Algebra 2, we're now going to learn how to solve quadratic equations two ways. One way, they'll give us the graph of the quadratic function, which is called a parabola. And that's going to be very simple. Where that graph crosses the x-axis, those will be the solutions of the related quadratic equation. And the second way is we're going to actually use factoring. We're going to set factors equal to 0. So here we go. To solve a quadratic equation related to the graph function, you simply identify that graph's x-intercepts. So the solutions to any function f of x equals 0, in this case quadratic would be ax squared plus bx plus c equals 0. But we don't need to know all that for the problems we're doing in this section. We simply look at the graph, determine where it crosses the x-axis, and those will be the solutions to the related function set equal to 0. In this case, we can see that the graph is crossing through the x-axis at both x equals 0, the origin, as well as x equals 2. And therefore, the solutions to that graph function are x equals 0 and x equals 2. Now we're going to work on solving quadratic, or any function really, set equal to 0 in factored form. Now our concentration in this section are for quadratics, but in this case I went ahead and showed you that it would extend to other polynomials of any degree n, provided we have it factored. So in this case we have this function 2x squared times the cube of x plus 2 times the binomial x minus 1, and that related function set equal to 0 is found in this case by setting each of the three factors equal to 0, because when one multiplies by 0, the product always equals 0. So we're going to set x squared equal to 0. We're going to set x plus 2 cubed equal to 0, and we're going to set the other factor x minus 1 equal to 0. A lot of times when I'm teaching, the students will say, well, what happened to the 2? Remember, this is a product set equal to 0, and unless it contains a variable, in the case of 2, we already know 2 is positive, so 2 can't equal 0. So it's not a case of where did 2 go, it's a case of we know 2 doesn't equal 0, so we don't solve for 2 equal to 0. But we do solve for x squared equal to 0, which is going to give us x equals 0 in a moment. We do solve for x plus 2 cubed equal to 0, which is true when x is negative 2. And we also solve for where x minus 1 equals 0, which is true for when x is 1. And there they are. Now, normally in Algebra 1 or even beginning Algebra 2, you actually add steps. You go square rooting both sides here, you cube root both sides here, and then subtract 2, and simply you show addition of 1 both sides here. But at this point in the course, and you being an Algebra 2 student, you can think more conceptually. That is, what number do you square to get 0? The answer is 0. What number do you cube to get 0? Well, 0. And so what number do you add to 2 to get 0? The answer is negative 2. And what do you subtract 1 from to get 0? Well, 1. 1 minus 1 is 0. So you can kind of bypass all those additional things that we normally do when we are in Algebra 1. Finally, we're going to go back to the old so-called bang-bang, the two-pistol technique for solving quadratic equations. You'll probably remember this, I hope you do. To solve 4x squared minus 11 equals 3. We see that we have x squared, so we know it's quadratic. That's what this chapter is about. We're going to first set this thing equal to 0 by subtracting 3 both sides. So to do that, we subtract 3 both sides. And here comes the bang-bang part of the problem. We're playing a two numbers game, but with tables. We have to set a table for 4, the lead coefficient. We have to set a table for the constant negative 3. Ways that we can multiply to get 4, 1 times 4, 2 times 2, or we can do 4 times 1. ways to multiply to get negative 3 are 1 times negative 3, negative 1 times 3, and of course we could reverse these. We could put the 3's on the left side and the 1's on the right. I don't overfill these tables. I try to keep the fewest number of values I can to start off with, because the goal is to find this linear coefficient, this number in front of x. And if I can find it with fewer numbers, it's going to be easier to find it than if I hide it like a needle in a haystack. So what we do is we take the numbers from the tables, in this case 1 and 4, and 1 and negative 3, and here's how we test it. We know we're looking to get negative 11. We take 1, we multiply negative 3 with it. 1 times negative 3 is negative 3, and then we do 4 times 1. 4 times 1 is 4, and then we add what we get from the multiplication. We have negative 3 here, we have 4 here. If we add 4 and negative 3, that's 1. Well, we're not looking for 1, we're looking for negative 11. So we know that did not work. Let's try the 1 and 4 again, because there's another pair of numbers we can try it with. So we have 1 times 3, which is 3, 4 times negative 1, which is negative 4, and if we add negative 4 and 3, we get negative 1. And again, we're not looking for negative 1, we're looking for negative 11. So we could continue to go through this list of values, but let's go ahead and find the ones that work to save a little time on this video. We have 4 times 3, which is 12. We have 1 times negative 1, which is negative 1. If we add 12 to negative 1, well, that's positive 11. We're not looking for positive 11, we're looking for negative 11. So that ought to hint us up. We want to use the 4, 1 and the 1, negative 3. 4 times negative 3 is negative 12. 1 times 1 is 1. If we add the negative 12 to the positive 1, there's the negative 11. So we want to use the pair of numbers from this table, which are 4, 1, and the pair of numbers from this table, which are 1, negative 3. And normally in class I go ahead and circle these, but for this video I did not. But we take two sets of parentheses. The 4, 1 from the first table tells me to put them in that order. 4 comes first in front of the x, and then the 1 comes second in front of the other x, but since it's a 1x, we normally don't put it. From the second table, negative 1 comes next. Excuse me, I did not use negative 1, 3. I used 1, negative 3. Excuse me. 1 comes next here, and then negative 3 comes last here. Always check. 4x times x is 4x squared. 4x times negative 3 is negative 12x. 1 times x is 1x. If we add negative 12x to 1x, there's our negative 11x. 1 times negative 3, there's our negative 3. So we know this is the correct factorization. To finish this problem up, we set the factors equal to 0. That is, we set 4x plus 1 equal to 0. We set x minus 3 equal to 0. Here we subtract 1, divide 4. Here we simply add 3. To finish this problem, doing that work gives me my solutions. X equals negative 1/4 and x equals 3. Again, your assignment for this lesson is on Gradebook Wizard, the website. So I need you to go to Gradebook Wizard, the website, and find the related assignment. They are textbook exercises from Chapter 7, Section 2. I believe the assignment is due Monday, May 4th. But again, double check all that to be sure. All right, see you in Zoom this week.